medicine and industry. In this session, we'll explore how radioisotopes are produced and how they are applied in the fields of medicine and industry, especially for radiography students like you. Close quote. Slide 2, Introduction. Open quote, radioisotopes are unstable forms of elements that emit radiation to become stable. These unique substances play a vital role in our daily lives, from diagnosing diseases to ensuring safety in industrial testing. Understanding their production and uses is essential for every radiography student. Close quote. Slide 3, Basic Principles of Radioactivity. Open quote, radioactivity is a natural process, where unstable nuclei release energy in the form of alpha, beta, or gamma radiation. Each isotope decays at its own pace, known as its half-life. Knowing the half-life helps radiographers plan tests and manage exposure safely. Close quote. Slide 4, Production Methods of Radioisotopes. Open quote, radioisotopes are mainly produced in nuclear reactors and cyclotrons. In reactors, stable elements absorb neutrons, creating isotopes like cobalt-60 or iodine-131. Cyclotrons, on the other hand, accelerate charged particles to produce isotopes such as technetium-99m. Hospitals also use isotope generators to create short-lived isotopes safely on site. Close quote. Slide 5, Common medical isotopes. Open quote, some common medical isotopes include technetium-99m, used for imaging organs and bones, iodine-131, for diagnosing and treating thyroid disorders, cobalt-60, used in radiotherapy, and fluorine-18, essential for PET scanning. Each isotope serves a unique purpose based on its type of radiation and half-life. Close quote. Slide 6, Uses in medicine. Open quote, in medicine, radioisotopes are used for both diagnosis and therapy. Diagnostic imaging techniques such as PET and SPECT allow us to see the internal functions of organs in real time. In therapy, isotopes are used to destroy cancerous cells while sparing healthy tissues. Tracer studies also help doctors track body processes, like blood flow or kidney function. Close quote. Slide 7, Uses in industry. Open quote, radioisotopes are not limited to hospitals. In industries, they help in non-destructive testing to check welds, pipes, and materials without damaging them. They're also used in thickness and density gauges, leak detection, and flow monitoring systems. These applications make processes safer and more efficient. Slide 8, Safety and handling. Open quote, working with radioactive materials requires discipline and care. Always follow the ALARA principle, as low as reasonably achievable. Use proper shielding, keep a safe distance, and limit your exposure time. Ensure safe storage, constant monitoring, and correct disposal of radioactive waste. Close quote. Slide 9, Future prospects. Open quote, the field of radioisotopes is constantly evolving. Scientists are developing new isotopes for targeted cancer therapy and improving cyclotron and reactor technologies. Artificial intelligence is also being integrated to enhance image quality and diagnostic accuracy. The future is bright, and radiographers will be key to applying these innovations responsibly. Slide 10, Summary. Open quote, let's summarize. Radioisotopes are crucial tools in both medicine and industry. They help diagnose diseases, treat patients, and ensure the quality of industrial products. Understanding their production, application, and safety measures forms the foundation of modern radiography. Thank you for watching, and keep exploring the amazing world of medical imaging. Close quote.